to my channel. Thank you very much for joining. I don't know why my screen is saying preview, but we're going to get this phone situated and start the live stream right now. So for today's video, I was asked to explain how to classify triangles according to its side and its angle. So we're going to be doing some questions related to that. But before that, we need to first cover the concept. Can you see? Cover the concept behind classifying triangles. I don't know why my phone is acting like this today, but it's okay. Alright, so when you're classifying triangles by side, there are three things you need to know. Is the three types of triangles that are there as it relates to your sides. They are either isosceles, scalene, or equilateral. And you know, isosceles triangles, we have two sides that are equal, and therefore the base angles are also equal. So the base angles here are equal, and so we pay attention to the base angles. Alright? So for scalene, you'll know that no sides are equal, and so that doesn't look right. Something like over here. So for scalene, we have no sides equal, and for equilateral triangle, we have all three sides equal, and then you know all three angles equal. But to classify it relating to its angle, we talk about it being acute, it being right, obtuse, or equiangular. So acute, the largest angle is less than 90. So this thing is not writing again, and I switch from the whiteboard, the same thing happening. So it's less than 90 degrees. For right angle, its largest angle is equal to 90, and sometimes you'll see the little elbow right here indicating that it is indeed a right angle triangle. For obtuse angle triangle, you realize that the largest angle is greater than 90. So the angle is greater than 90, but it is less than 180. And for equiangular triangle, you'll realize that all angles are equal, meaning they all equal 60 degrees. So that's basically how you classify triangles based on sides and angles. So if you're given a question, give me a sec, guys. If you're given a question, let's add a page. Like this one, and here is 118 degrees, and you're asked to describe this triangle based on its angle and its sides. You know that the largest angle, thinking about the angle, this angle here is 118. That makes more than 90, but it's less than 180. So you know for the angle, it's going to be obtuse, and for the sides, based on what we're seeing here, no sides are equal because we don't see the line going through any of the sides. We're not giving any measures, so we say it's obtuse, scalene. Let's try another one. So this one, here is 60, here is 60, and here is 60. Oops, this measure here is 7, that's 7, and that's 7. So for that one, it's asking you for the angle and for the sides to classify it. Again, all three angles are equal. So for the angle, we say it's equiangular. And for the sides, we say it's equilateral. Alright, and that's basically how you do a question like that. Another one could be drawn like that, and they're gonna ask you to do the same thing, classify them. So right here you see the elbow, which basically mean right. So for the angle, it's a right angle. And for the side, since we're not giving any measures and we're not giving the indication for the side, we know that the sides are not equal. In this case, we're going to write scalene. Alright? And this is an example of an equilateral. So let's put isosceles up here. So let's say that one and this length equals that length. Alright, like this one, guys. So we're given that these two sides are equal and this angle up here should be 90, not drawn to scale, so please forgive me, should be 90 degrees. So right here we see for the sides, since two sides are equal, that means that these two angles are also equal. So for the sides we say it's isosceles, and I cannot spell this word to save my life, isosceles, and for the angle we say it's right angle triangle, because this 90 degree up here indicates that it's a 90 degree angle. The elbow you see there indicate 90 degree. Alright, let's move on. So we could also be given the length of three sides to determine if the angles are equal or the lengths are equal. So we classify this by sides. So to do this, we need, why am I saying this twice? I don't know, wait first. So I think this one should come first. Okay, so this is it. So find the measure of sides ABC, then classify each triangle by its side. So I think I skipped one page over. So with this one, you have two ways of doing it. You either graph this with these 2 points, or you can use the distance formula to find it. So the distance formula, so the distance between 2 points, so 2 points have the values have coordinates, x coordinates and y coordinates. So you're basically going to be labeling them. So we're going to take each point going to be x1 minus x2 all squared plus y1 minus y2 all squared. Alright, so we're going to be finding the distance of each point. So if you look at this, given as A, B, C, we can first find the measure of AD, and this board keeps moving and I don't know how to make it stay in one place. Distance of AB, then we find the distance of the last two, BC, then we find the distance of the first one and the last one, AC. And if you graph this, you should see the same thing happening. So let's do a small sketch of the graph right here for the persons who are visual learners and wondering why am I picking it like that. So let's say, alright, we have negative numbers more than positive, so let's say -1, -2, -3. Let's count up here by 2, so 2, 4, 6, -2, -4, -6. So the first one is saying 8, -6, so let's say 8 is here, so 8, -6 is the point A right here. -1, -4, it's going to be the point right here, and that's B. Then we have -3, 6, which is another point. Let's change the color. -3, 6. So that's 1, -4, so that's B. And over here represents A. -3, 6, -3, 6 will be somewhere up here, and that's C. So if you connect these points, you can determine if it is scalene, isosceles, or equilateral. Alright, so some persons like to do it this method, and some persons will ask you to work it using the distance formula. So based on what we're seeing right here, mine is not drawn to scale, but these lengths don't look equal to me. So I'll say it's scaling. So let's see if my answer is correct, since as my diagram is not drawn to scale. So we're going to use the distance formula to find this. So as I was saying to you, the sides to use AB. So AB, you see, is one side. So the first two ones. Then BC is right here. Then AC would be the other one. So that's how you determine which two sides to use when you're working. So let's go. So the distance formula AB is going to be the square root of x1 minus x2 all squared plus y1 minus y2 all squared. So first thing you need to do is to label your points as x1, y1, x2, y2. I'm going to call that x1, y1, x2, y2. Then we fill them into the formula right here. So x1 is 8 minus x2, which is negative 1. Then we have y1, which is negative 6 minus 4 all squared. Once we see two negative signs, we know our next goal is to have addition. It's going to be the square root of 8 plus 1 all squared plus negative 6 plus 4 all squared. From here, we're going to have 9 squared plus negative 6 plus 4, negative 2 squared. We always put negatives in parentheses, as that's how your calculator will read it if you use a calculator. But we always advise to use parentheses and having negatives, so you know that it's the number by itself. I'm going to put the answer right here. So 9 squared is 81. Says 81, and negative 2 squared is 4. So that's going to be plus 4. So the square root of 85 is going to be the answer. You can leave your answer in the radical stage, or you can convert your answer to decimals. That's perfectly fine. But radical stage will help you to see if the numbers under the radical sign are the same thing or not. So let's move on to this region. I'm going to erase this side because I need more space to write to solve for BC. So BC, let's do the same thing. So I'm going to erase that one. I'm going to label this one x1, y1. Alright, so let's go. So negative 1 minus 3 all squared plus negative 4 minus 6 all squared. Negative 1 plus 3 all squared plus negative 10 all squared. Negative 10 squared is going to give us 100 plus negative 1 plus 3, that's 2. And 2 squared is 4. So this one is going to be the square root of 104. So let's identify some answers. So we have one answer right here, and that's BC. And we have one answer right here, and that's AB. So look at them. If we know that both are equal, we know it's isosceles. No side equal, it's going to be scalene. All three sides equal, it's equilateral. So let's go find the length of AC. I'm going to work that one to the top because I don't have enough space at the bottom. So let's go. So AC, I'm going to erase this. I'm going to call this x2, y2. If you want to write the point of AC here, so it's easier for you to see, that's fine, but I'm going to work it as it is. So remember, I'm using the formula for the distance formula. So I'm going to say x1, y1, so it's x1, so that's negative 3 minus 8 all squared plus y1 is 6 minus 6 all squared. These two make a positive right here, so that's going to give me 6 plus 6 is 12 squared. And negative 3, negative 8, that's negative 11. Negative 11 squared. So 11 is 121. I need a calculator to add these two. So 144 plus 121. So here is 144, here is 121. That gives me 256. Wow, that's a pretty long line. But you guys saw the line, how long it was. So you have an idea of what it is. So my first idea was that the scalene triangle, and it is indeed correct because one length is root 85, one is 104, and the other one is 265. So we say it is scalene if you look at the length of the triangle. And so that's how you work question that involves you given 3 sides of a triangle and you classify them based on its sides. So I hope this was useful. I have a few more things to cover, but I don't want the stream to be too long, so I'm going to end this stream and we're going to start another one where we can explain another concept better. Thank you guys for joining. Remember to like, comment, subscribe, tell a friend to tell a friend, send their questions over, and I'm happy to help them.